Okay, everybody. So it looks like we have Dylan and Joseph already here. So Dylan and Joseph, can you see me and hear me okay?
Yeah, I can see you and hear you.
All right, Joseph. And Dylan is here too, I think.
Yeah, I'm here. Yeah, I can
All
see
right.
you. You're good.
Okay, so just want to make sure. Anyway, so I just want to make myself available to take questions, and we can go ahead and get started. It's 4 o'clock. So is there anything you want to ask about?
Yeah, I got a few.
Okay.
Yeah, so I was going back and I was rewriting all the questions from the homework quiz for 3 and 4, and I have like it's like a lot of just little questions that relate to like a few of the questions. Um, well, so for example, on the number 1 from the quiz 3,
Okay.
what exactly does x approaching c without the negative or the positive, or left or right, what does that mean exactly?
So you said question 1 from quiz 3, was that right?
Yeah.
Okay. So that has 3 parts to it. Let me write them down. It has the limit as x approaches c from the right for f of x. It has the limit as x approaches c from the left. And then it has the limit as x approaches c. Now, let's see. This is the one that we learned initially, okay? Which I guess in informal terms it says, what happens to y if x were to get closer and closer to c from either side? And then this
Okay.
is the same thing from the left side only, and this is the same thing from the right side only. So let's take an example to solidify that. So say we've got this graph like so, something like this. This is kind of a roughly generic picture of the kind of stuff that we've seen. Let's say like C is this number, all right? And we'll say this point's open, and we'll say this point's open. And say like this is 5 and that's 1. Okay, so and this is the graph of some function f of x whose formula is not given to us. Well, what happens to y as x were to approach c from the right? That's the first question. Well, what's the pattern if you were to plug in numbers closer and closer to c from the right-hand side? So just think about that. I mean, we can make a table if you want to. There's lots of ways that limits can be done. But, for now we're thinking like, say you're going like this. Well, that's going to force the y to, it looks like it'll be like 4.8, 4.9, 4.99, 4.999. Looks like as x goes to c from the right, it's going to push the y closer and closer to 5. So, all right, 5's our answer for that one. From the left, it's going to be 1, right? But what's the limit as just x approaches c? So that's the one I think you were initially asking me about, Joseph. So what do you think?
That won't be the does not exist.
Does not exist. Yeah, if you say what happens to y as x approaches c closer and closer from either side, we can't say that y goes to any particular spot, okay? That's true. But let me ask you, as it is, this picture, what is f of c? So f of c,
Would be, I mean, whatever the x value would be.
Well, so according to our picture, since this point was deliberately left open, and so is that one, and those are what is right above c on the x-axis, there is no y coordinate for x being c.
Undefined?
undefined. That's right. So as it is, this is undefined. Okay. But what if I had this question a little bit different? Say that this point was included. You know, because it could have been that way. I just created this example, you know, just to get us going here. But that would change to what? F of C is 1, right? But would that change this answer? So
No.
suppose that I changed my graph and I said, oh, it's actually, when you plug in C for X, according to that point being there, you get 1 for Y. Is that going to change anything about this limit, though?
It'll still be.
Still be does not exist. That's right.
Yeah.
It wouldn't change it. Okay, so there, I think I went like way beyond what you wanted to ask.
Yeah,
but
yeah.
As you
Appreciate that.
mentioned this question, it reminded me of some other things in some of the other quizzes. Okay, so how's that sound, Joseph?
Yeah, that's perfect. Yeah.
Okay. Well, we can try and take turns here between Joseph and Dylan. So Dylan, do you have anything that you want to ask?
Okay, so in quiz 3, okay, so I did this problem and I took a part out, but I still got the same answer, which I then figured out how to do it. I just want to make sure I'm doing it right. So
Okay.
I did do it right and then get it right, just making sure. So number 8, and it's the piecewise
Number 8.
function.
Okay. Yeah, I see it. So it's the one that says find constants A and B such that the function is continuous on the entire number line. So does that sound right?
Yeah, so at the first time I did it, I don't know why. Well, I wrote it out. I guess I was going really fast. And then towards the end, you know, where I did it the whole wrong way. I don't know what I was doing. Anyway, then I figured out what I was doing. So I did it like a more complicated way. I took a B away. Don't know what I was doing. Anyway, and then I did the 2-part. Explain it.
Here, how about this? Let me go ahead and copy it down because in case somebody else wanted to ask about this one or see it later on. Okay, so this the one that says f of x equals, and as I'm looking at your quiz, it's 7, and then ax plus b, and then -7. And the ifs are if x is less than or equal to -3 for this one. And in the middle, if x is between -3 and 4. Okay. And the last one, x is greater than or equal to -4 or 4. There it is. And so then the question's like, well, what's the a have to be, and what's the b need to be? So let me see if I'm thinking about this the way that you were. If this is going to be continuous. Oh, well, I mean, like, I thought I heard you say something about using 2 equations.
Yeah.
But let's do this. Like, if this is going to be continuous, then this formula needs to be equal to that one at -3. You know, because think about it. If this wasn't continuous, then, you know, the first formula wouldn't pick up where the second one left off at, and then the third one wouldn't pick up where the second one left off at. Okay? So just in general, you know, if this right here is -3, if the functions are not equal at -3, then the graph's going to be disjointed. Okay, I need them to be equal. So it's going to say this: I need 7 to be equal to ax plus b if All right, well, where might they be disjointed? Where does this one pick up from where that one left off? At x is equal to -3. So I need that to be true. But also, I need the same thing to hold between these two. I need ax plus b to be -7 if, all right, well, this one picks up at 4, which is where that one leaves off at. So if x is 4. So I need -7 to be ax plus b if x is 4. Okay. So now you mentioned you tried it 2 different ways. This would be the right way to go. All right.
Yeah, I did it this way the second time.
Okay. Well, that was, I saw that you got it correct. So yeah, it was that second way.
Yeah, then I saw that I got the right stuff. I was like, oh, cool.
Okay. So you were thinking about it correctly then.
Yeah.
But I wanted to describe the setup in a way that it might be easy to remember it later. So does that sound okay for you?
Yeah, that's good.
All right. So it's like these gaps, these equations are like closing these gaps. All right. On that graph. Okay. Now from here, like once you realize to do that, you plug in -3 for x and you plug in 4 for x, and you get a system of 2 equations and 2 variables that you solve. Okay. All right. So Dylan, we're doing okay with that one then, right?
Yeah.
Okay. Well, let's go back to Joseph. See what he wants to talk about.
Okay, so on number 4, I understand how the answer is equal to 1 because they're both the same answer. But whenever Alyssa was talking about it, she said to be careful whenever the x is approaching from the left, because it could mean that the answer, something along these lines. I wasn't too sure. I was kind of just scribbling it down when she was saying it. But I guess, could you give me like another example of how that would work? Or would it matter if it was approaching from, let's say, for the left? Would the answer still be 1?
So this is for question 4 in quiz
Quick,
3.
Yeah.
No, it would be different. It would be different in this case. Let's talk about this in some detail. But I can give you the short answer. The short answer is it wouldn't be the same. Okay. But let's take one that's a little bit different than that one, if you're okay with it.
Yeah, that's fine.
So let's say we had x minus 2 over x minus 2. This is a lot like the one you were doing. And we want to do the limit as x goes to 2 of f of x from the right, and then the limit as x goes to 2 from the left. Okay, now the question you're talking about, just ask about the right-hand limit, but it could have asked about the other one, and we should make sure that we can do both of them, right? And they will be different in this case. Maybe not in all cases, but in this case they will be. Okay, so first of all, I want to deconstruct this because this same function appears in some other problems that ask for different things. So let's see. I'm going to make a table. I'll see if you can agree with my table. I want to find a pattern in the way this thing works. So first of all, isn't it true that this function f of x is undefined at 2? Sorry, I put -2. This function f of x, this is undefined at 2. That's right. Because if I plug 2 in for x, I'll get 0 over 0, and that is undefined. So I'm gonna write that down, that this is undefined at 2. But if I were to put in 3, 4, 5, 6, 7, all those, here's what you'll find, that function calculates y to be 1 in every single case. For example, if say you put 7 for x, 7 minus 2, that's 5 over 7 minus 2. That's 5. 5 over 5 is 1. So any input bigger than 2 will give you 1 for y. And if I put in anything less than 2, say 1, for example, I'll get -1. Okay? If I put in 0, I'll get -1. If I put in -1, I'll get -1. All right? So part of what I wanted to tell you is that this function can be reduced to this. It will give you -1 for y if you plug in any value of x less than 2, and it will give you 1 if you plug in any value of x that's more than 2. This is just purely a matter of fact about how this function works. Whether you use the formula or whether you follow these directions, that's exactly the way the math's going to work on it. Okay, I'll say one more thing though. Is there I made a table. I just plugged in numbers to that function to see this pattern to it. That function gives you a -1 or a 1, depending on whether you plug in a number bigger than 2 or less than 2. Is there some other way you can come to that conclusion? Well, what's the difference between absolute value x minus 2 and x minus 2? Well, if this number were to be positive in there, you would be dividing a number by itself, which is 1. And if that number were to be negative, you would be dividing a number by its opposite, which would be -1. So maybe thinking about it that way, it's not too much of a surprise how it works. Okay, now I'm going to graph it because that's something I usually do in case it helps people see things. Here's the graph. So we get that it's undefined at 2. We get that the function is 1 for values of x bigger than 2, and -1 for values of x smaller than 2. We get that it's undefined at 2, which is what the open circles tell you. So there's our graph right there. If you were to graph this, it would look like this. If you were to graph this, it would look like this. That's just what it is, it turns out. All right, Joseph, so I've told you some things about this that are beyond what it's directly asking for in the question, but you'll see this formula again, so I wanted to make sure and explain a few things about it. Now that I present it to you that way, if I can tell you that this function has this graph, which is a fairly simple graph, can you tell me the value of these limits?
Yeah. As it approaches from the right, it'll be +1. If it's approaching from the left, it'll be -1.
Very exactly.
And
And so maybe now does that make it seem a little more obvious why?
Yeah, that
why?
does. Definitely
Okay.
does.
And I just wanted to stress that because I think you were saying that you weren't exactly sure why it would be different from one side versus the other. Okay. And here, you were able to tell me what it was from either side. Does that sound okay, Joseph?
Yeah, yeah. Thank you. Appreciate that.
Oh, okay. So looks like in the meantime, we've had somebody else join us. Czar, just want to make sure that you've got a good connection and that you can see and hear everything.
Yes, sir. It kind of keeps freezing in and out, but I can see everything pretty well.
Okay. Well, I am recording this and I'm going to post it later too. But so far I've given everybody a chance to ask about something. So it's your turn now if you have anything you want to ask about.
Yeah, I mean, I guess, I really don't know where to start, to be honest. I've been trying to, I don't know, I've gone through all the videos again, written down everything. I'm just kind of not grasping this information. I'm just so used to being able to get this is how you do it, this is the steps, this is exactly what you take to get here, and I'm just having a very, very hard time grasping the idea that, especially when it comes to the tables, when you're putting in the numbers that aren't the same as as they're not any specific numbers that you're putting in, they're different numbers every time. I'm just having I don't know, I'm just getting kind of super overwhelmed with all of it. I don't really even know where to start, to be honest.
Well, so the part of the issue with what we're doing is it's not as black and white like algebra or pre-calculus was, because everybody could use different numbers to find the same patterns. Okay, so for example, if let's say I'm gonna like get a clean slate here. Let's say like here, let's take this one. So f of x equals x squared if x is less than 2, and x plus 2 if x is greater than 2. All right? And say our question says, what's the limit as x goes to 2? So, all right, first of all, what does that mean? Or what's it asking us? The limit as x goes to 2, f of x. It means in this function, if you were to put in values of x that were successively closer to 2, what would the pattern be for the y? And there's no black and white answer to what numbers you would use to find that pattern. There just isn't. But we'll generally do the same thing though. For example, if I want to see what happens when x approaches 2, first of all, I'm talking about on a very small scale with numbers that are very close to 2. So if you look back in the video, normally we do something like 1.8, 1.9, maybe 1.99. Okay, that's a series of numbers that are getting closer to 2. Could I have used 1.97? Yeah, I could have, and maybe I would in one video, but it's still, we can see a pattern here that I'm pushing closer to 2. Now, what about from the other side? Maybe like 2.01, 2.1, or something like that. Okay? Could you use slightly different numbers? Yeah, you can use 2.02 and 2.2, but the idea is that right there, this or something like this is what x going to 2 looks like.
Yep.
All right, so next thing, I need to put those values of x in for y and see if there's any pattern. Okay. All right. So 1.8. Let's start with that one. How do you put 1.8 into this function? Where does it go?
You just replace it with the x, or?
Yeah, this x or that one or this one or this one. We just replace it with the x, but we have to follow the instructions. This says y equals x squared if x is less than 2, and y equals x plus 2 if x is greater than 2. So I'd be using this one.
Yep.
Okay. So when I plug in 1.8, it's going to be 1.8 squared. And then I'll get my calculator. I'll figure out what that is.
3.24. Yeah.
So 3.24. So then I get a number. 3.24. 3.9 with that, and then I get 3.61. 1.99 squared. I do that, and I get 3.96. And I can sort of see a pattern there that from 3.2 to 3.6 to 3.9, that the closer the x went to 2, the closer the y so far is going to what looks like 4.
4, yeah.
But that's a pattern. Like how many numbers you need to see a pattern might be different than how many I need or somebody else's. So far, that's what it looks like. The x goes to 2 is pushing the y to 4. But let's try the rest of the numbers on the table. 2.01. 2.01 is bigger than 2. It would go right here. That will be 4.01. And 2.1. That again is bigger than 2. It would go in that bottom formula. That's going to be 4.1. So here's the pattern that we need to see. If the x gets pushed to 2, it's going to push the y to 4. And that's what the limit's asking us. cause and effect. If you push the x to 2, where does that as a result push the y? And so that's one kind of problem. There are lots of other kind of problems that are in the videos and so on, but that's one kind where, you know, even though somebody could use different numbers than me in the table, we have more or less a black and white way to go about doing it. All right, so that's one thing. Now, in your case, like, we would have to take this one problem type at a time. As we talk about this one, Czar, how does that sound?
Yeah, I understand that.
Okay, so that would be an example of something that if you saw that, at least in your mind, you'd have a clear-cut way to approach it.
Yes, sir.
Okay, so what I need you to do from here is go through the quizzes, you know, one problem at a time until you get to that one example where you think, I don't know where to begin, and then talk about it.
Okay.
So that would be the right way to go about it. And of course, like, do that as soon as possible, you know, so like, say like first week of school, second week of school, we start quiz 1. Go through it. If we encounter some difficulty, we address it right then, right away. Always ask for help as soon as you possibly can. Okay, so we'll circle back around to Czar. Let's see, I asked Dylan, I can't remember who was last before that, Dylan or Joseph. Y'all have to remind me whether Dylan or Joseph had the last question before that.
You know, I just didn't go first to be once. I don't really mind.
So Dylan was, well, it's okay. Let's do, I think I did answer his before we went to Czar. So let's do Joseph and then Dylan and then circle back around to Czar. So Joseph.
Okay, yes, I have a question for quiz 3 and number 6. So I tried using more examples, but they all kept having removable like, I guess, part for number 6. And is it non-removable because the x values are both 4 on the piecewise function, and one of them doesn't work while the other one does work? If that
Okay,
makes sense.
so find the x value for whichever is not continuous. Is the discontinuity removable or not? Okay, so let me give you an example that's I don't want to use, if you're okay with that exact question.
Oh, that's fine.
But let's do something like it that has like exactly the same concept. So hold on. Let me look at your quiz in a little more detail. Okay, so that one is like this. And let me use a variant of that question I was just using a minute ago. Okay, so first of all, this function, as it is, I'll say a few things about it working up to answering your question. But first thing is it's not continuous at 2. Okay? Are you comfortable with that statement, Joseph?
Yeah.
Okay, well, let me ask you then, why don't you think it's continuous at 2?
Well, I know it's not because of the less than on the first x squared. It just being underlined signifies that it's just undefined at that point specifically.
Yeah, but this other one is the one beneath it. This one is defined at 2. You see?
Then we would have to, I guess, do the math for it and figure out if they are on the same line.
Whoops.
To see
I was
if
trying to
it'll.
divide my page in half. Sorry. Well, here, let's take 2 and compare then. All right. And these will look very much similar, but they will be different with regards to what you were asking about. Okay, Joseph, so there's not much difference between these. But the claim that I'll make to you is that the one on the left is not continuous at 2, and the one on the right is continuous at 2. Okay? And here's what I want you to notice about it. About where does this formula put you at 2? Can you tell me?
Maybe put, I guess, 1.9 squared would be,
Wouldn't 1.9 squared be about the same thing as 2 squared?
yeah, it's off by
Yeah.
0.40 or 0.39.
Yeah. So, I mean, or think of it like this. Do you know what 1.9999999 squared is? I don't know what it is, but I bet it's about 4, because 2 squared is 4. Does that seem reasonable?
Yeah,
Okay. So this is going to put you near 4, this right here. As you go towards 2, this is going to put you close to 4. Is that safe to say?
yes.
And where's this one going to put you at 2?
So greater than 2. I mean, it'll still be a little bit over 4.
Yeah, but let's say if this one picks up at 2, which is where this one leaves off at, doesn't this give you 4 at 2?
Yeah.
And then where did we say that would leave off at? Like what, 1.9999999 squared? What's that going to be?
It'll be at the
About
same
4.
point.
Yeah, so this one's continuous, okay? Now, if you were to draw a graph in as much detail as you could ever imagine, this is what it would look like, okay? I'm going to sketch it right now. You would get this parabola up to 2, okay? And it would look kind of like this. And this point would be open, okay? That point at 2 and this point being at 4, right? Isn't that what we said? What's 1.99999 squared? It's about 4. It'll be open at 4. And then we pick up with this other one right here at 2 itself, and we put 2 in and we say 2 plus 2 is 4. And so that means it's going to pick up right where this one leaves off at. And it otherwise is a line that has a slope of 1, like that. So there's the graph. That's what it would look like. If you plotted points all day long and connected them into a picture, that's what that picture would look like. Okay, so that's why this one is continuous at 2. This formula will pick up exactly where that one leaves off at. And then here's what our graph is going to be. All right, so Joseph, what I'm trying to get you to see is that this other one is not like that. All right? We can draw the graph if you'd like to, but you don't have to go in that much detail if you don't want. So again, this right here, that's going to leave off at about 4, okay? 2 squared is 4, so if you're some number that's just barely less than 2, when you square it, you'll about get 4, okay? And does this one pick up where that one leaves off at? Does this one pick up where that one leaves off? It doesn't. This one picks up at 6. This one's going to leave off at about 4, and then this one will pick up squarely at 6. And so here's the difference. Visually, this is why I'm trying to get everybody to be able to see, is that we're going to go like this. Okay, so that's going to be 4 and 2. So that parabola y equals x squared, so long as x is less than 2, is this much of the curve. We'll have this open point at 2 for x and 4 for y. But then this other one, y is x plus 4 if x is greater than 2. The very first point on that for y is 6. So we're going to go off like this. We get a line that has a slope of 1 from there with this point right here at 6. Now, there's the difference between them. This one is not continuous at 2, and it's a non-removable discontinuity, also called a jump discontinuity. The graph abruptly jumps from this to this one leaving off at about 4, and then this other one picking up, jumped all the way up to 6. That's why the answer for that one there was that it was not continuous and it was a non-removable discontinuity. It's a lot easier to think of it as a jump discontinuity, but I guess that's not sophisticated enough on WebAssign. But if we look back, Joseph, could we tell that it would have been this way? I'm trying to see if I can get you to understand the difference, but also get to where you do this a lot faster. I knew that this one would be continuous because this formula leaves off where that one picks up at, which is 4. And I knew that this one wasn't going to be continuous because this one leaves off at 4 and then the other one picks up at 6, which is in a totally different spot. All right. Okay, Joseph, so I gave you a pretty long answer to your question, but I'm just hoping I can get you to see the difference there. You sound okay?
Yeah, you definitely did. On that note, then, what would a removable discontinuity be called then? So it's non-removable is a jump.
I'll show you real quick. So let's see. A non-removable would be something like, or a removable would be something like this. So you had f of x equals x plus 4 if x was not 5, and 4 if x was 5. Okay, so let's see, what's that going to be? I'm going to do this. Let's say this is 4 and 9 and 5. Okay. Now let me sketch the rest of the graph in place, and I'll tell you from there how I get it. Okay. So here's my example. Here's my function. And here's the graph. All right. So why is this the graph of that function? Well, because this function is x plus 4 if x is not 5. What is y equals x plus 4? It's a straight line. It has a y-intercept of 4. Okay? And it would have this point 5 for x, 9 for y, if I wasn't excluding 5 from the definition of it. That's why this point's open. Then if you read the second part, it says y is 4 if x is 5. Well, that's a point. 5 for x, 4 for y. Okay? So this one is not continuous. It's definitely not continuous at 5. But it's a removable discontinuity. The reason why it's removable is because we could say this is not continuous because of that number misdefined right there. What would this number need to be for this to be continuous? You can actually make it continuous. You can remove the discontinuity. So are you able to tell me, Joseph, if I were to scratch out this number, yeah, 9. I mean, so that's why it's removable. Okay, so it's like thinking, well, if that was a 9, then it would fill in this point right there, and then it would be continuous. So that's why it's called a removable discontinuity, because that can be adjusted like that. Okay, so does that get everything straightened out for you, Joseph?
Yeah, thank you.
Okay, so then it's Dylan's turn. So Dylan.
Oh, hello.
Hey there.
Okay, so I'm 22 on quiz 3 and 21, I think it is. The last questions, basically. It's like I think I understand the concept. Give me a second. The part where it's like the greater than and then non-greater than is the difference in both of them.
Mm-hmm.
Is
Yeah,
that what's
so
determining like how it's continuous and how it's not continuous, meaning true or false?
well,
In that game?
exactly. So and let me try to give you something real quick to show you why that would make the difference. Let's see. Let's take the one we were just talking about. So
Because it's
that,
better when you draw it out, right? It makes more sense, right? For these ones.
well, you could do the whole test in your head. Like you don't have to draw it
Yeah.
out if you're comfortable with that. But I'm saying like if you're at all not comfortable with just looking at a formula, then sketch the picture of it. You know.
Yeah.
But so that one I was just doing, that was what, x plus 4
Yeah.
if x, well, let's do like this. If x is less than 5. And then let's do 9 if x is greater than. So that's similar to the last one. It's not exactly the same though. So let's see. Is that continuous at 9? Well, that's the question I want to pose. Or is that continuous at 5?
At 5, yeah. Right?
Well, let's see. Let's see. Continuous
wait.
at 5.
No, because they're both open points.
Yeah, exactly. Exactly. And I think that's what you were starting to realize on that question, those last two questions of quiz 3. Because if I
Yeah, I was just
say,
making sure, like, is that what the point of those was? Is like to show that difference from that
yeah,
by
yeah,
looking
just
at.
so we
Okay.
can notice the details there, the
Okay.
smaller
That makes
details.
sense. I did stare for a
So,
second and then I went back to it and I was like, oh, okay, that makes more sense now. I was gonna make
yeah,
sure.
because you can tell me, so let's see. Let me sketch it because I'm recording this for others. The way this formula is, this would be the graph. We get this line up until 5, but it is actually undefined at 5. So that point that's open because of it being strictly less than should be at whatever 5 plus 4 is, which is 9. And then this is 9 if x is strictly more than 5, but once again the point 9 and 5 is not included because of that. And so it's not continuous at 5. Okay? So is it continuous at 5? No. And what's the reason? Well, the only reason is because that point right there is missing. Okay? That's the only reason. But what if I did this? Is it continuous now?
Yeah, because it fills in that break.
All that does is fill in this point. Oh, geez, I don't know what that is. Y'all can see that. I don't know why that showed up. But that's obviously out of place. Oh well, I can't make it go away. Yeah, geez. Well, anyway, but yeah, so that sounds like that's what you were on to, and you just wanted some confirmation that you were understanding it correctly. And then that's true. You were understanding it the right way. Okay, so Dylan, did I touch on what you?
Yeah, but I'll let the next person go. I mean, I have a question on quiz 4.
I got you. I just thought, like, since we have several people, we take turns.
No, you can go to the next person.
Yeah, we'll come back around. So let's see, back to Czar then. If you have a question, Czar, we can talk about it now. Going once, twice. All right.
Okay. Sorry.
There we go.
My mic wasn't working. What about, can we do question 6 and quiz 2?
Okay, so 6 in quiz 2. Let's look at that one. Okay, so you said 6 on quiz 2?
Yes, sir.
Okay, so find the limit of the function as x goes to 9, x squared minus 81 over x plus 9. Okay. So let me write that down so nobody has to look back at their quiz. So limit x goes to -9. All right, limit x goes to -9, and it says x squared minus 81 over x plus 9. Okay. Okay. So now there's 2 parts to this question, but that's the first part, is just to do this limit. So limits can be done with tables, and that's something that I illustrated already, is that you can take a table and basically do that like that question I did earlier. So that's one option. Another option is to look at a graph. Okay, and so far with some of the other problems, I've drawn some graphs and I've asked you how you can do the limits based on the graph. And then the third option is you can reduce what you have. Okay, so this is one of the problems where it would probably be best to reduce what we have. The reason why I say that is because x squared minus 81 is the type of thing that we know how to reduce. Like when we take algebra, we learn how to do things like factor and cancel like terms and so on. So on this particular question, because of that, I'm not going to use a table. I'm not going to make a graph. I'm going to reduce it just because I recognize that as the kind of thing that we learn how to reduce in algebra. Okay? So, all right, let's take this and just reduce it. X squared minus 81 over x plus 9. Okay? So yes, in algebra, we learn how to factor things like x squared minus 81. And I say in algebra we learn that. I mean, you may not remember everything you learned in algebra, and that's okay. We can review it, but that is called the difference of two squares. It does factor.
Mm-hmm.
And it factors as x plus 9 times x minus 9.
Yep.
So I'm just
That's
taking
that a
advantage
squared
of that.
minus b squared, right? That's like.
That's right. That's right. And so say I do that, like you're saying, the formula is usually given as a squared minus b squared. Then I notice that the x plus 9s being similar will cancel, and it will leave me just with x minus 9. So it reduces quite a bit. It reduces to something that is a lot simpler than what we started with.
Mm-hmm.
So what that means is now I have a much easier way to answer this initial question. I can see it as what's the limit as x goes to -9 of x minus 9. Okay?
Mm-hmm.
And so to do that one is fairly easy. I can plug -9 in for x to discover the limit, and I'll get -18. Okay? And why does it allow me to plug in -9 for x to do this limit? Well, a minute ago I was asking Joseph something like this. Say you want to do the limit as x goes to 4 of x squared. And I think Joseph was saying like, well, you have to do like 1.99 squared. And then I said, well, what's 3.9999999 squared? I don't know what that is, but I bet it's about 16 because 4 squared is 16. So in cases like that, you can just put the number in to do the limit. And that's what I did here. The limit as x goes to -9 of x minus 9. I can just put -9 in, It's negative 18. If you didn't want to do that and you wanted to put negative 9.01 in, you're going to get about 18 doing it that way. Okay, so Zara, that's that question 6 from quiz 2. That's the part of it that requires the work, the reduction, the simplifying, and so on.
Mhm.
That help you see the right way to approach that one. There is also a second part to it. So let's say part A here and part B of that question. Or I should have written this as question 6 from quiz 2. 6 from quiz 2. Part A, the limit is negative 18 by this. Part B, all right, it says write a simpler function that agrees with the given function at all but one point. All right. So let me pose this to the class. Is x squared minus 81 over x plus 9 really just equal to x minus 9? So think about that. And whoever thinks they know the answer to that, tell me. Is x squared minus 81 over x plus 9 equal?
It should be.
Kind of like, but is it like 7 plus 3 equals 10? Well, think about it. Like x is a letter of the alphabet. X is a letter of the alphabet. Letters aren't equal to each other. Only numbers are equal. I can say 7 plus 3 equals 10. Those are numbers. But this X is a letter. Math deals with numbers. So do you think no matter what you put in for X, this formula is going to calculate the same answer that this one is? Is that true?
No.
Or I'll tell you what I'm getting at. If you put in, you see this formula here? If you put negative 9 into this formula, what do you get?
It's zeros.
Wait, no.
Here's 0.
Yeah, see, he says zeros. You get 0 over 0, which is what?
Which is
I
mine.
think it's DNA.
Yeah, D&E.
Yeah.
There's no answer to that. But say you put negative 9 over here, what do you get?
Negative 18.
Negative 18. Or are they are they equal? Is
No.
0 over 0 equal to negative 18? Definitely not. All right. So whenever I reduce this, it's not really equal to this thing. It's equal to it everywhere but at negative 9. Okay. So in part B, it's saying there's a little bit of fine print up there. This thing here is equal to this thing here with some fine print. And that fine print says this.
The if statement.
Yeah, only if x is not equal to negative 9. Okay, so that's the part of it in part B it's asking for. It says, what's a simpler formula that agrees with the one you started with except at one point? Well, yeah, this does reduce to that much simpler formula except at negative 9, then they don't agree with each other at all. Okay, so there's both parts of question 6 from quiz 2 for you. There's some fine print, there's an if statement. Letters of the alphabet are not equal to each other. You got to think about numbers. Part B involves a lot of things that are sort of subtle, easy to miss and easy to misunderstand. But now that I've said all that, Czar, there might be some of that you're not so sure about. So do you have anything to ask about what I said just now?
So the answer is just, there is no answer?
Well, the answer is part A is negative 18.
Yeah, I understand that. Part B, yeah, because it's like it says use a graphing utility to do this. I mean, so I'm saying, so the answer, it really is just saying that there is no answer, right?
Oh, no, the answer to part B is x minus 9.
X
Okay.
minus 9. Okay.
Yeah, but I was explaining the reasoning behind it.
Okay.
Okay, so the answer is usually not that hard. or that complicated in itself. The reason for it is usually a much bigger story. So answer to part B, A is -18. Answer to part B is x minus 9. I'm going to go ahead and share my screen and show that quiz question, because I was answering it without actually having the question up for everybody to see. So I'm going to share the screen for a minute, and we're going to go over to my math lab. Here it is. Here's the question I was looking at. And we did that first part. We got -18, no problem. Write a simpler function that agrees with the given. Oh, that's the given function, x squared minus 81 over x plus 9. Write a simpler function that agrees with that at all but one point. Okay, x minus 9. X minus 9 agrees with this at all points but one point. The point where they don't agree is at -9. That's where they don't agree with each other. You put any other numbers in and they will be in total agreement in their calculations. Okay. In the course information, let me show y'all something real quick. So everybody always read the course information. In here, I can't remember where it says it. I think it's about under the assignments part of it, when it talks about the assignments being on WebAssign. It says some of the questions may mention something about use a graphing utility, but you never have to do that. I'm not using graphing calculators in the class or expecting you to know anything about it. So always just answer the questions as they are and ignore anything about calculators. I can't remember where in here it said that, but it was there somewhere. Anyway, okay. So back to rotating around for questions. So we answered Dylan and Joseph and then Czar's question, and let's go back around to Joseph.
Yeah, I got a question on quiz 4 for number, I believe it was number 7. No, sorry. Yeah, actually it is number 7. Yeah, number 7. At the end of it, so I did the watch the video section of it, and then they, I guess it's more or less, what's the name of the y minus y1 equals mx minus x1 equation? And I'm guessing that's just like the y equals mx plus b.
Okay, let
Or
me.
how would that one work?
So you're saying? Oh wait, I just realized I know this is probably not of great importance to y'all at this point, but I remembered where I found that. Okay, so here's the course information. It's right under the calendar. Where do I complete the assignments? On WebAssign, it says parts of the questions on WebAssign that call for the use of graphing calculators or graphing utilities are not required, so you can always ignore that. Okay, so I got that off my mind. So let's see, let's do this. So you said y2 minus y1, right, over x2 minus x1. And you were curious, like, what is that formula? Is that right?
Oh, no. So, I mean, because the one they used for the video, it was y1, I mean, y minus y1 equals parentheses x minus x1. Which, I mean, I guess it would make sense coming out of that equation, the y2 over y1.
I think you're thinking about this one.
Yeah.
Yeah, so that's called the point slope formula. Okay, for the name of it. Now, was your question, what do you use that for? Or what is all the stuff in it? What's x2 and x1 and what's m?
No, so I know that. So I guess I'm guessing this equation would be used whenever formula.
Well, let me answer.
Whenever I'm just giving just one specific point.
I never ever use this for anything. It's completely unnecessary. But you can use it. And of course, you watched that video and they brought it up and used it for something, and that's okay. But you don't need to. You can use this for everything. You know, in every question I've done in the videos, I only use this to answer it. Any question that involves a line and the slope of the line and a point on the line, you can do all of that with this one thing. Okay? You could use this one too if you wanted. But it doesn't matter. You know, I'm definitely not forcing you to use one or the other. Just if you like the first one, use the first one. If you're copying the way I'm doing in the videos, they'll all be done with the second one.
Okay.
That sound all right? So that way, like, you're not forced into either one of them. Probably what you saw was
Yeah.
that you knew the slope and you knew a point and you wanted to find the equation. That was probably the question, right?
Yeah. Because we were just giving one x and the point value for the y and the x, and then it gave us I guess the other x was squared. So I mean, I was trying to figure out where that equation came from, so I was a bit confused because they used it like in 2 videos, I think, and I couldn't find it anywhere else.
Well, it's called the point slope equation, and you can use it like say you know like the slope is 4 and there's a point on the line 3 and 9. You know, 9 being 3 squared or something. Let's just say that's it. Then yes, you put 4 in for the slope, and this would be an x coordinate we can call x1, and this would be a y coordinate we can call y1. Okay. All right. And then you put all that in. You could use this one though in the same way. All right. So I'm not forcing you one way or the other, but it sounds like you were able to get that question right from looking at your quiz. And this is just an alternate form of that one, really. Okay, so
Okay.
let's see. So let's go to Dylan next. So Dylan, if you have something else.
On that problem that we just did, I feel so dumb. Okay, so when I was doing it, I did it the YMX plus B way. But when I was like subtracting my half, I forgot, you know, a half out of a half, just a positive. I don't know, I think I was doing it too fast and I just forgot I don't know why I put negative for some reason. So I sat there for like a solid minute wondering what I was doing wrong the whole time a while ago.
Oh,
But,
okay. But you figured it out though, right?
Yeah. I was just like,
That happens.
what am I doing
You'll get
wrong?
lost.
Huh?
Yeah, it happens to me too, though. That same thing happens to me too.
Like, why did I put a negative? What?
Well, I found that the better I got at math, sometimes the lazier it made me.
Yeah.
Like, I'm not saying that happened to you, but just I would be less careful because I wasn't worried about making mistakes. But anyway.
Yeah, I just like go through it and then I'm like, oh, well, I skipped something. Probably shouldn't have done that. And then I have to go back and I fix the whole thing and then I get the right answer.
Gotcha.
Okay, so quiz 4 has got me a little stumbled more than the other ones. I understand all the other quizzes. I think quiz 4 is stumbling me because like we're dealing with 2 points, and then I understand, but I know we're using the slope formula, and then we're using the 2 points to correspond how to find either. I don't know. I think I'm getting confused because I know there's the tangent line, and then there's the secant line, but it's the only quiz that's confusing me because I know those two are in it, and then finding the slope.
Yeah, so that's a common point of confusion.
But I think it's because I keep mixing all of the. I don't know what's going on.
Well, okay. Let's take an example. Say we got this curve, and I'll keep it simple for now. But f of x is 3x squared. Okay. Part 1. What is the slope of the secant line? So I'll do SL for secant line through. Let's do x is 2 and x is 2.1. Okay.
Yeah.
All right, so here's what that represents. And I'm going to draw a curve here. I'm going to draw a picture because I think that often makes it easy for people to remember. But
See,
you've got this
That's why I like
curve.
the pictures as well.
Yeah, well, I do think that for some people, it does help you keep everything straight, all the ideas.
And being
So
kind of visual helps.
yeah, and there's a lot of people that are like that. So yeah, that's my working assumption is that people are going to be visual. So here's this curve in blue, and here's 2 points. Here's a point where x is 2, and then over here is this point where x is 2.1. Okay?
Mm.
And the secant line would be this line that I'm about to draw in red that goes through those points. Okay? So that's the secant line.
Yeah.
So if I reinterpret question 1 here, it says, what's the slope of SL means secant line through those 2 points? Well, there's 2 points that are on this curve here, this one right here, and I just want to know how steep that line in red is. So truth is with this one, that's just algebra. There's an equation for that, rise over run. Now, I guess in order to do that, I would need to know the y coordinates for these points. So like with this one, the x is 2. What's the y coordinate? Well, 2 squared, that's going to be 4 times 3 is 12. So here's your y coordinate. And this other one where x is 2.1, what's the y coordinate there? Well, I'd have to do 3 times 2.1 squared. Okay,
to find your other
that
y.
would be 13.23. So there's my points are completed. The question only gave me the x coordinates for the points, but they're on that curve, and I can use the formula to find the y coordinates. Okay, so my answer is going to be 13.23 minus 12 over 2.1 minus 2. Right? That's just rise over run. And I'll do all my math there, and I'll get 12.3. Okay. All right, so 1, this is what the secant line is. And 2, that's the question you would encounter is to find its slope, and that's just rise over run. This deal right here, this thing I just wrote down, that's our rise over run formula from algebra. The other way that this question might present itself in quiz 4 is what's the slope of, I'm going to write TL. TL means tangent line at a certain point. Let's say at x is equal to 2. And this is where it would be an honest mistake to get confused about these. The secant line and tangent line might sound like similar things, and I guess they are similar, but as far as the calculations, they're different. How do you find the slope of the tangent line at all? Okay, how do you do it? The derivative, which we call f prime, tells you the slope of the tangent line. All right, so f prime, what's f prime? Well, there's different ways of calculating f prime addressed in the videos and so on. For now,
Is
just
it
to do
okay if we use the way if we know how to do it?
Yeah,
Like we already know how to.
in general, yes, but part of our class is learning the difference quotient, which that's the limit as h goes to 0. So there will be 2 questions where you do it that way, just to show me that you can, because that is part of one of the objectives of our class. But just if you follow the instructions in it, the question says to do it that way, then just do it like that, and then you can use shortcuts in all other cases.
So the way to tell the difference with these, with the the secant and then the tangent. So the way to tell the secant is where it's either going to be with points and you're finding a slope, and then your tangent line is either going to be derivatives with points and using slopes.
Basically, yeah.
Okay.
I
still understand the difference between them.
Or could you just look at it as 2 points and 1 point?
Yeah, so the secant line will involve 2 points and the tangent line just one. You
Yeah,
could
that
also
too.
think like, people in the everyday, have you ever told somebody that, or heard somebody say that they're on a tangent
Oh yeah,
conversation or something like that? So the tangent line, by definition, intersects the curve at only 1 point, and then they diverge. So it's like you're going on the curve, and then there's this point where the tangent line and the curve meet each other, and then the tangent line veers offwards from there. So the tangent line meets the curve at only 1 point. If we're having a conversation and I go off on a tangent, I'm following the conversation, then I go off in some other direction, you know,
yeah. Yeah.
from what we're talking about, right? So yes, the tangent
Mhm.
line meets the curve at 1 point. Questions about tangent lines will always only involve 1 point, right?
Okay.
So
Yeah.
y'all brought up some ways you can remember it, and it's whatever works for you.
Yeah.
So let's see. The slope of the tangent line is found by the derivative. If you want to know what the slope of the tangent line is at the point where x is 2, then I'll just need to find the derivative and put 2 in for the x. Okay, so that's 6x is the derivative. The slope then of the tangent line is 6 times 2, which is 12. Okay?
Mhm.
There, so that's like sort of a fairly quick overview of quiz 4. Now, these are similar, right? The slope of the secant line is 12.3. The slope of the tangent line is 12. Is it a coincidence that they're almost equal to each other?
Yeah, one's just gonna be a little more accurate than the other,
Well, I guess that's one way of thinking about it.
basically.
But it's specifically that the secant line, sorry, is trying to be the tangent line.
Oh yeah, yeah.
Like, think about it. What if I push this point closer to that one, this 2.1? What if I push it closer to 2? It would look more like the tangent line.
Mhm.
If I take the secant line and I push this point closer to that one, it's going to start to look like this. And this is going to turn into that number. 12.3 is going to turn into 12. Oops. Okay. So now that was like quiz 4 is a big quiz with a lot of stuff on it.
Yeah,
And
I think that helped a lot more. Yeah, I just had
yeah,
to find the difference, the
yeah,
split point.
and it will take some,
And
but
that's what I
I
needed.
mean, in the course information, you can use notes on the quiz or the test, and if it helps you to organize
Yeah,
your thinking, write it all down, then go ahead and do that. It's no
I
big
understand
deal.
all the like concept stuff. I just didn't understand what goes to what. I think that's the missing piece of that.
I got you. I got you. Well, okay, so I got
Mhm.
time for one more question. I have another class that's having a test soon this weekend. So Audrey joined us. I just noticed your name as I was doing that last question. I'm not sure when you joined, but I just noticed it, Audrey. So if you can see me and hear me okay, let me know. And if you have a question, uh, let's hear what it is.
No, I don't have a question. I'm just listening in again.
Okay, gotcha. Well, that's fine.
Thank
So let's go
you.
back anytime. Let's go back to Czar then, circle back around. And this will be the last one that I have time to take today. You can email me over the weekend with more questions, though. I'll be checking my email.
Well, I guess I kind of want to just go back to what he was kind of talking about. So just question 2 on quiz 4. So you're saying
Okay.
that you just plug in that 2 into to the x, and so you would just get. So you're saying that it would just be 2 squared minus 3. Is that what you're saying?
Well, so let's do this. And I think I can take what Dylan was talking about a little bit further. Now, there's a lot to learn in calculus. A lot of people think it's difficult. The math is difficult. The concepts are difficult. And it's going to take some time to get your head wrapped around everything. So let's hold on. Let me see. Let's start this way. So here's the formula in that problem on the quiz you were talking about. It's x squared minus 3. Okay. So x squared minus 3. And it says, what is the slope at the point where x is 2? Okay. Yes. All right. So x is 2. So is -1 the answer?
No. Oh,
Squared is 4 minus 3 is 1. Okay, is 1 the answer?
no, it's not.
Yeah, not the answer. Well, what is that though? Okay, so say you had the curve f of x. There is a point on the curve where x is 2 and y is 1. But what's the slope of the curve at 2? Well, to figure that out, we'll need to use the derivative of the curve, which is f prime, which in our case here is 2x. So the value of the derivative at x being 2 is f prime at 2. And okay, that's going to be 2 times 2, which is 4. Okay, so here's the things that we need to think about. There's the curve, there's the point on the curve, and then there's the slope at that point. There's 3 different things, all related in different ways for those questions. Whoops. I was wanting to draw a straight line there. Okay, so in red, that right there, that's the tangent line. So TL, what's the slope of the tangent line? 4. Okay, so everything is in my picture. I've got the curve. I have the point 2 and 1 on it, 2 for x, 1 for y. In red there is the tangent line at that point, and its slope happens to be 4. So just in one picture, that's kind of a quick summary that contains everything. The curve, the point, the tangent line, the slope. And that's a fairly simple thing, and many of the questions are harder than this one, but this does encompass all the ideas in one place. So at least you got the ideas sorted out in your mind. So Zard, so the answer there for that question, it's 4, but in addition to that, I drew the sketch up there to tell you how it all fits together. How does that sound to you?
Yeah, I mean, I guess I understand. I mean, I guess I get it.
Well, that's the first part, is like
Yeah.
you can see the difference in all these things, okay? That you can, in your mind, you know the difference between the curve and the tangent line and the slope and the point. Because if we don't know that, we can't do anything that's more difficult. If we know that, then we have a chance to apply some math to something that's a little harder about this. But anyway, okay, so unfortunately I said I could only do one more before I have to go to my next session. But I'll be checking my email. If you've got questions, I want to hear them. Sometimes when people ask a question, I'll sketch the solution out on paper and scan it and send it back. Sometimes I can just answer it directly in the email. It just depends on what you ask. But let me know, and I'm going to open the test up tomorrow. So you can take the test tomorrow or Sunday, and it's due Sunday. All right? But anyway, any final questions about the test itself before I sign off?
It's so good to hear that you said it would be open tomorrow. I worked the day of the test, so I wasn't gonna have much time to do
I'll
the
always
test.
have it open for at least 48 hours. So
That's
yeah,
good.
it'll be open. In fact, if you stay up late, you can take it after midnight tonight.
You know I am. God, you know.
Right. There you go. It'll be open after midnight. Anything else? All right, everybody. Glad you could join. And you know where to find me if you need help.